Assalamualaikum. So let's start our lecture. Last class we stop at here. Are you ready? Sama close the door. Basil, close the door. Door. Please sit down at your place. Sorry, like that. Okay. Last class we stop here. The PTA, how to develop the PTA, the heat cascade. Okay, where we had gone through how to get the minimum hot utility. Okay. Just a recap. Once you obtain, by assuming the first cascade, 0 megawatt. Okay, so pass through the delta H. Heat required. Are you ready or not? Please focus. I want to recap because we are behind time already. I need to speed up. Okay. Now for the heat cascade, the PTA, first cascade we assume 0 megawatt. So moving down on the delta H, surplus and deficit, we find out what is the highest negative value. So the highest negative value is your minimum hot utility. Okay. This one. Okay, taking that value, proceed to the second cascade, where you should find until you get 0 megawatt. Where this 0 megawatt describe the pinch point. Okay, at 0 megawatt over here, this is your pinch point. Okay, to get the hot pinch, add up 5 degrees C. Cold pinch, reduce 5 degrees C. Why add 5, reduce 5? For the hot and cold pinch. Why do you need to add 5 and deduct 5? This is the pinch point. Hot pinch 150. Cold pinch 140. Why do you need to add 5 and minus 5? Correct. We shifted earlier by 5 degrees C. Okay, so to get the actual hot and cold temperature, hot and cold pinch temperature, you need to shift it back. Okay, as I mentioned earlier in the final class, here, this is the pinch point where 145, okay, 145. When the H is 0 megawatt, okay, at this point. So to get the actual hot and cold pinch, you need to shift it back. That's why hot, you get 150, move up back. Cold is 140, move down back. Okay. So 145 is not your final answer. You need to find out what is your hot pinch and cold pinch. Okay. Now we do the second exercise. Next exercise. where here it gives you only the PFD. Okay, it gives you only the PFD, where you were asked to calculate the minimum hot and cold utility at the location of the pinch. Okay, assuming delta T min here is 5 degrees C. Now, you are given this PFD. There is no labeling for hot and cold. So you need to label it on your own. First step must be correct first. Okay, the hot and cold stream labeling. Now, even though you have answers in your slide, I want to go step by step to define the hot stream and cold stream. Okay, so we go from the feed here, 20 to 0 degrees C. What is this, cold or hot? Cold or hot? High to low. Hot. Hot stream. High to low. Decrease. Okay, it doesn't matter whether it is at 20 degrees C or -1, as long as it occurs decreasing temperature. It is hot stream. Okay, so this is hot stream. Now, effluent of the first column, here 19 to 20. Cold. Cold, eh? 19, -19 to -20. Hot or cold? Hot. Hot. Why hot? Not cold. Reduce temperature. Okay, you see, even though the temperature here is negative, the classification of this stream is hot because it reduced the temperature. -19 to -20. It's getting colder. So reduce temperature. This is also hot. Okay, here 19 to 20. Cold. Increase temperature. Cold. Okay, cold. Okay, now -39 to -20. Sorry, -39 to 20, not negative. Increase cold, cold stream. Okay. Now this one, -1 to 20. Cold or hot? Dialan. -1 to 20. Cold. Cold or hot? Cold. Yes or no? Why do you say cold? Why do you say cold? Right. Wong Jian Ming. Cold or hot? -1 to 20. Cold or hot? Cold. Cold hot. For those who haven't get the idea how to classify the stream, you will get 0 marks for question 4 in final exam. Okay, question 4 in final exam is related to the heat exchanger network. So if the first step you don't know how to classify, the rest of the question you cannot answer. Definitely 0 marks for that. Okay, first step is to know how to classify the stream. Abdul Aziz, this stream is hot or cold? -1 to 20. Cold. Why do you say cold? Increase temperature. Okay, so this is cold. Okay, how many streams we have now? Total stream that need to do the heat integration. Hot, hot. Okay. Now, first thing on the classification of the stream. This is cold, cold. Okay. Now, how many streams in total that you need to do the heat integration? How many? 5. 7. 7. Yeah, this one random numbering, not following the exercise yet, random one, okay? Just to number, to count the stream. 1, 2, 3. Okay, here you see there are 2 different temperature from the initial -39 to 40. One time change temperature. Okay, this is stream 4. -40 to 20. This is stream 5. Okay, 5. This is 4. Now here, -1 to 0, stream 6. 0 to 27. Okay, so that's how you number the involved stream for the heat exchanger network later on. Okay, now we are done with step number 1. Define hot stream and cold stream. Okay, then it asks you to calculate the value of CP for each stream. CP is not given. How do you want to calculate the CP value over here? For stream 1, what is the CP? Correct. Okay, the formula for CP is delta H over delta T. Okay, that is right. Now for stream 1, CP delta H 0.8 over 20. 20 or negative 20? The delta T. How do you calculate the delta T? TS minus TT or TT minus TS? Huh? TT minus TS. So it will be negative. The negative and positive sign is important. Huh? So it will result in negative 0.8. Sorry, 0.04, correct. 0.04, yes. .04. Okay, so do the same for the rest of the streams. Where stream 2, it will be 1.2 minus, divide by negative 20 minus negative 19. Okay. Okay. What you get? Positive or negative? Positive or negative 1.2? Positive. 1.2.
Minus then minus negative
Negative or positive? In your slide, positive or negative? Positive. Negative. CP, not the delta H. CP. Positive. Okay, from the calculation here, by right, it should be negative, right? Okay, now, why it is negative on the delta H? We miss out the sign on the delta H. Sign on delta H. Okay, here, back to stream 1, 0.8. Here you supply heat or you receive heat. Sorry, here you supply, right? To reduce the energy, is it? Stream 2 over here. Supply hot utility or cold utility? Okay, I go straight away to this. You see, Okay, this one, this slide, you see the delta H over here. Negative 0.8, negative 1.2, and negative. Why it use the negative sign? Delta H negative means what? Heat supply or heat sinks? Heat supply, negative. If positive, what does it mean? Okay, looking back to the PFD, now 0.8 just now from the table, it put as negative sign. We look as overall later on. Okay, now this one is negative as well. This is negative 0.8. Okay, 0.6 is positive, 40 to 20. This is positive. Okay, then from stream 6 over here is negative 1 to 0. This is positive. 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 Down here is positive. Okay, so you need to know the heat, the delta H sign first, whether it is negative or positive. Hot stream, negative sign. Okay, hot stream, negative sign. Cold stream, if you notice, positive sign, which means heat from the hot stream will be sink to cold stream.
There is stuff like that. So you really should be in the participate. There is heat supply there.
20 to 0.
So, but there is heat supply, right?
0 point, what do you think?
Supply is minus.
Minus and
Delta.
not minus 20.
I mean, 30 is minus.
It gives out heat. Okay. Now, first you need to get that correct, the sign. Hot stream, negative signs. Okay. Cool stream, positive signs. Okay, the delta H. Then from there, you calculate your CP. Okay, CP. Now, from the CP here, Next step, once you calculated the CP, next step, find the shifted temperature. Okay, so these are done. Once you get your CP, next, calculate the shifted temperature. Now, the shifted temperature shift down by 2.5. Why 2.5? Why you need to shift by 2.5, not 5? Delta mean divide by 2. Okay, why 2.5? Delta T mean divide by 2, which your delta T mean is 5, 2. So that's why you need shift by 2.5. Okay. Then set your shifted temperature T as TT for each stream. Okay, just now, before you come out with this one, you should list down all the stream first. List down the stream. Okay, the 7 stream. List them out and categorize into hot and cold. Easier to see later on. Okay. Okay, moving forward, find your shifted temperature. Hot minus minus 2.5 for hot. Cold plus 2.5. Okay. Cold plus 2.5. Hot minus 2.5. Okay. Then, yes. Correct. Okay. Then carry out the heat balance within the each shifted temperature. You arrange the interval temperature first. How do we arrange this interval temperature? Descending order, correct. From the shifted temperature. Okay, from all these shifted temperature, go descending order. Okay, so from here, from the green color one, you see the highest temperature. Highest is 22.5. Okay, so put up here. Then descending order for both column. Okay, so 22.5, then 21.5. Okay, then 17. Until the lowest point is 42.5. Negative 42.5. Clear? Okay, again, arrange the interval temperature based on the shifted temperature in descending order. Okay, next, do the stream population. Okay, stream 1 from 17.5 to negative 2.5. So you do here, stream 1. From 7.5 to 2.5. Drag down the arrow until negative 2.5. Okay, do stream by stream. Put label the CP. Easier for your calculation later on. Okay, label the CP over here. Next stream from negative 25 to negative 22.5. 21.5 to negative 22.5. Okay, stream 2. Drag down. Okay, this one for hot. Let's see for the cold. The last stream from negative 37.5. Okay, from here to 22.5. Drag up. Okay, until 22.5. Okay, then after you finish with the stream population, calculate the delta T. Okay, delta T here is the interval between the zone. Interval between the zone. Cannot see. Okay, between the zone, the interval. This amount, that value is not fixed. I mean, not fixed for each of the exercise. It won't be the same because it depends your interval temperature. Okay, this one is based on your interval temperature. How get 22.5 minus 21.5. Okay, so find the delta T for each interval. You have a big area up to 19 delta T, and you have 1 as your delta T. Okay, up to there? Chelsea, do you understand? Why you are not focusing? You don't need to write anything? How do you know this is correct? Write something. Make sure you write the notes. Write the step by step how to do it. Okay, after you get the interval, find the summation of the CP. Okay, the summation of the CP, you must get it correct. Okay, summation of the CP. CPC minus CPH. Because later it will determine the positive and negative signs. Okay, now CPC, I enlarge a bit. Okay, how do we get this 1.22? Total of CPC, CPC means the cold stream. Okay, cold stream. Which one is the cold stream? I erase that. Which one is the cold stream? Arrow going down or going up? Going up. Okay, so we have here stream 4, 5, 6, 7. Cold stream 4, 5, 6, 7. Okay, now summation of cold stream minus CPH. Now this interval has only cold stream. Okay, so sum all the CP 1.2 plus 0.01 plus 0.01. Okay, it involves stream 4, 6, and 7. Any hot stream involved? No, right? Okay, in this interval, there is no hot stream. So total of CPC 1.22. That's how you get 1.22. Okay. Interval, second interval, we have two streams of cold stream, stream 6 and stream 7. Okay, so here is 0.01 plus 0.01. Stream 6 and stream 7. That's how you get 0.02. Okay. Now the next interval, negative 0.02. Summation of all. So it involves cold stream of stream 6 and stream 7, which is 0.02, the summation of cold, minus, now it touch stream number 1, which is 0.04. Okay, so 0.02 minus 0.04. Then you get negative 0.02. Okay. Any question up to there? Understand? How do we get negative 1.19 over here? So 0.01 minus? Yes, 1.2, correct. Okay, so negative 1.19 over here, it involves stream 7 and stream 2. So 0.01 minus 1.2. Okay. Second column. Which one? For yes. No need, because it is not in the zone. Okay, so this stream, it involves only stream 6 and stream 7. That's why 0.1 plus 0.1. Don't confuse with the number boxes. The boxes for the number. Focus on the arrow, starting and end of the arrow. Okay. Now this delta, sorry, this CP Why is it 0? Gwendolyn, why is it 0? No stream involved in this zone. No stream. So that's why this is 0. Okay. Now, last one, negative 0.8. Why do you think negative 0.8? Why is negative 0.8? Cold stream or hot stream? Stream 3 is cold or hot? So how you get negative 0.8? Sorry? Yes, before you know it has surplus. How do you know how do you get that negative? From just now we mentioned CPC minus CP hot. How do you get negative 0.8 over here? Okay, here CPC minus CP hot. Here it involves only hot stream, no CPC involved. Okay, so CPC is 0 minus 0.8. So that's how you get 0.8 by calculation. Negative 0.8 by calculation. Okay. Any question before I proceed? That one is for the summation of the CP. Now we need to find the delta H for each zone, for each interval. Okay, so delta H, the CP multiplied by delta T. Okay, CP multiplied by delta T. That's how you get this figure. 1.22. So 1.22 multiplied by 1. Okay. Then from there, we categorize the heat is deficit or surplus based on the sign. Negative will be surplus, positive will be deficit. Surplus means you need to supply. Gain. Gain. You gain heat from that stream. Deficit means you have to supply heat, extra heat. Surplus means gain heat from that stream. Cannot see it. Okay, so after we obtain all the values over here, then only you can proceed with the heat cascade. Okay, get the delta H correct. because we need to proceed for the heat cascade. Wait, I'll make it bigger. Okay. Okay, next step is for the heat cascade. Start by assuming 0 megawatt. Okay, we go down one by one. First assumption 0 megawatt. This is the first cascade. Okay. Then from the delta H that you obtained from the table just now, positive 1.22 means you need to supply heat to it. So you need to supply. That's why here negative sign. Supply the heat. Okay, you need to understand this, supply and gain. Negative outside the box here on the cascade means supply heat to the stream because the stream requires 1.22. Okay, the deficit just now. So you need to supply negative 1.22. That's why the negative sign. Moving downward, the next stream, it still needs 0.08. Okay, so you supply 1.22 just now that you need to supply. Now supply 0.08 more. So equals to this amount. Accumulate, it is accumulate. Okay, supply 0.08. So accumulate from the top over here, you get negative 1.3. Means up to this stream, you need to supply this amount of heat. Okay, up to that. If you need to repeat, just ask me. Because this is confusing if you don't understand the sign. Huh? Yes. Right. First assumption always start with 0. Okay, because why? From the first assumption, we need to find the highest negative value. Okay. Now moving downward. Sorry. The next interval, you gain heat. Negative in the box. Delta H in the box is negative. So that means you gain heat. So total now, this gain. So you get back 0.3 megawatt. Now become negative 1. 1.3 plus 0.3. Plus here means you gain. The delta H here. The delta H here is the one you calculated earlier. Negative sign means you gain the heat. Okay, gain the heat. So here you gain 0.3. Gain. Okay. These two column is different. In the box is from the stream. Outside the box is the one that you supply or gain. Okay. In the box is from the stream. Outside the box is the accumulation of the heat you need to supply or gain. Okay. I repeat again. That's why here we start from 0, meaning that we have nothing, no gain or no supply yet. Okay, so moving downward, first interval you need to supply 1.22. So this column is the one, the accumulation of the heat, whether you need to supply or you need to gain. Okay. Now here, moving downward over here, next box, positive 0.77 means you need to supply 0.77. Okay, so here, supply 0.77. So the initial one, negative 1, that you need to supply, then add more 0.77 that you need to supply. So that's how it becomes negative 1.77. Okay, accumulation. Now, okay, going to this, you gain 0.12 from this stream, gain. So gain, you add 0.12. That's how it becomes negative 1.65. Okay, so now this box you need to supply negative 019. You need to supply this amount. Okay, so that's how it becomes like this. Okay, so this box positive means you gain. So become like this, negative 0.65. This one you need to supply. Okay, supply 0.15. Okay, this 0.65 plus 0.15, then you get negative 0.8. Okay. Next box is 0. So nothing happened. Still the same. The amount of heat still the same. Then the last box is negative 0.8. Okay, now, why here becomes 0? Correct. Why it becomes 0 here? Because from this box, you gain the heat, gain. So summation of this becomes 0. Okay. Now, from the first cascade, we check which one is the highest negative number. Here, the negative 1.84. Okay, this is the highest number for negative value. Okay, then taking that value, we do the, okay, how you define the lowest negative value? Correct. Okay, that's correct. Maybe my statement confused you. I mean the highest means the highest number with negative value. Okay, my statement just now, highest number with negative value. You can also use the term lowest negative value. Okay, what I meant just now, my statement, I said highest number with negative value. Highest number with negative value. Okay, or you can also classify it as the lowest number. Yeah, okay? It's just the term, how you understand it. Two. Yes. Okay, why we need to do the first cascade? Why you need to assume 0? Why do you need to start from 0? Because we want to know what is the minimum amount of hot utility that we need to supply? Okay, so negative 1.84 is the QH min. This is the QH min. Okay. So first cascade to identify your QH min. Now using that QH min, then we move to the next cascade, second cascade. From the first cascade, we already identify. We already identified the QH min that we need to supply. Okay. Now using that value, let's say you have 184. Okay, the amount that you get from the first cascade. Moving down to the first box again. Okay, using the same delta H again. Positive means gain or supply in the box. Supply. Okay, that means you need to supply this amount of energy. So here, supply. Okay, supply. Negative 1.22. Okay, 1.84 minus this, you get this. Okay, going down 0.08. Here, supply. Because the delta H is positive. Okay. This box negative 0.3 means you gain it. You gain the heat. So here plus 0.3. Okay. Here supply. Yes. Positive. Uh-huh. Yes. Okay. From the first cascade, we get negative 1.84, meaning that that amount of heat that need to be supplied to your system. Okay. Hot utility, heater. You need supply heater for that amount of energy. Okay. Then, for the second cascade, here we assume that 1.84 has been supplied to the system. Now you have already 1.84. Okay, has been supplied and you already have 1.84. Moving down the cascade, repeat the same thing. Delta H in the box positive means you need to supply. Okay, meaning that from the energy that you have just now, here you need to supply. So minus 1.22. 1.84 minus 1.22.
1 point, not negative 1.
No. Okay, why here 1.84 is no more negative? Because we have supply to the system. Meaning that you already have that 1.84.
It will be the same concept for every.
Yes, correct. From the first cascade, 0 because nothing being supplied. Okay. Second cascade, your objective is to find the heat accumulation until 0. Okay, so you must find until you get 0. This 0 point is your pinch point. What if you don't get 0? Huh? No pinch point. Means you cannot identify what is your minimum cool utility and hot. Okay. Now, once you get 0, that is your pinch point. Okay, moving downward until we finish the boxes. Here means gain. Okay. Then supply. Here 0, no changes. Here you gain 0.8. Okay. Now, the final amount over here is your QC min. QC min. First cascade is to identify your QH min. Second cascade to identify your QC min. Your QH min, your QC min from the heat cascade must be the same with the composite curve. Okay.
Starting point to last point. Or, okay. Like from here, we started from 1.84, right? And then we also finish at 1.84.
No, it depends to your delta H.
It's not necessarily the same.
No. From the previous example, it's not the same. It depends to your delta H. Yeah, don't get confused. The QH min and the QC min is not necessary to be the same. Not compulsory to be the same. In this example only, eventually they are the same. Okay, so the previous example, which is QH min is 7.5, QC min is 10. Previous example. It's all based on your delta H. Okay, it's all based on your delta H. The boxes over here. Delta H for each interval. Okay. Now, since we get the zero value at the pinch point just now, here is your pinch point. Okay, the pinch temperature over here is negative 21.5. Pinch. Okay, this is not yet your final pinch point. You must identify the hot pinch and the cold pinch. Hot pinch, what you need to do? Add 2.5 back. Okay? Add 2.5 back. That's how you get 19. Cold minus 2.5. Okay, I repeat. The hot and cold pinch, how you get? From the pinch point over here, which is 21.5 degrees C. Okay? So to find the hot pinch, negative 21.5, shift back, shift to the top back. Just now to get the shifted temperature, we shift down. Now to get the actual temperature, shift up back. So that's why add up 2.5. Okay, cold pinch, reduce back. Good.
The first cascade gives you the cold pinch. And you add 2.5, you get the hot pinch.
The first cascade. Again, repeat your question.
Get the first pinch point, the cold point.
Yes.
On the first cascade.
Second cascade. This is second cascade. The one that you get 0. This 0 point is equivalent to this interval. Actually, you should put the temperature again in here. So it will be clearer to see lah. Okay. Okay, again I summarize. Heat cascade, the first cascade is to find your QH min. Once you get your QH min, move over to the second cascade to find your pinch point. How to determine your pinch point? Until the accumulation of the heat over here equals to 0. Okay, that is your pinch point. Hot pinch, add up the delta T min over 2. Okay, in this case, delta T min is 5. So that's why I add up 2.5. Cold pinch minus delta T min over 2. Okay. Okay, clear. Okay, please make yourself understand on this part, because tomorrow we will go for the below pinch and above pinch analysis. then you will need to identify how many heat exchanger that you require. Okay. Next class, I will proceed with this slide. This slide. Okay. Later I announce in CN. Okay. Please make sure you understand today's lecture in order for you to understand tomorrow's lecture. Okay. Okay, so for those who haven't scanned for the attendance,